You're playing quantum Russian roulette. The only version of you that survives is the one that was lucky enough to be in the branch where you didn't die. Every single time. You should take that as good evidence that the many-worlds interpretation of quantum mechanics is correct. For decades, scientists have been searching for the theory of everything, the ultimate framework that could unify all of physics into a single coherent model. This theory aims to bridge the gap between Einstein's general relativity, which explains gravity and the motion of massive objects, and quantum mechanics, which governs the strange and unpredictable behavior of particles at the smallest scales. While both theories have been extensively tested and proven in their respective domains, they contradict each other when applied together. This fundamental conflict has left physicists searching for a missing link, one that would unify the macro and micro scales of the universe under a single set of laws. Various attempts, including string theory, have tried to solve this puzzle, but none have fully succeeded in explaining how the universe truly works at every level. Now, a new player has entered the game, Google's Sycamore quantum processor. Unlike classical computers, which process information using binary code, strictly zeros and ones, quantum computers operate using qubits, which can exist in multiple states at once. This allows them to perform calculations far beyond the reach of traditional systems, opening doors to uncharted territories in physics. Recently, Google's Sycamore chip executed a series of groundbreaking experiments that produced results no scientist expected. The data hints at physics beyond the standard model, the current framework that describes the known fundamental forces and particles in the universe. If these findings hold up, they could indicate a fundamental shift in our understanding of reality itself. But what did Sycamore find, and why are physicists suddenly questioning the laws of reality? Google's quantum chip breaks the rules of physics. Google's quantum chip, Sycamore, was designed to push the limits of computation, but no one expected it to break the fundamental rules of physics. In a recent experiment, researchers tasked Sycamore with running an extremely complex quantum simulation designed to analyze particle interactions at a fundamental level. The goal was to test known quantum principles, but what happened next left scientists stunned. The results contradicted established quantum mechanics. The behavior of certain particles did not follow the expected patterns. They moved and interacted in ways that shouldn't be possible under our current understanding of physics. Quantum mechanics, despite its bizarre nature, is extremely precise. It predicts probabilities in particle states with near-perfect accuracy. Yet, Google's experiment produced anomalies that defied these rules entirely. Some scientists are now speculating that these results may point to a hidden layer of reality, one that classical physics has never been able to detect before. If true, this could mean that our current model of physics is incomplete and that a deeper set of laws governs the universe at the most fundamental level. Could this be the missing link between quantum mechanics and general relativity? Could it explain why we haven't yet found a theory of everything? Dr. John Preskill, one of the leading experts in quantum physics, has described Google's advancements as a window into a new reality. He believes that these experiments are not just technological breakthroughs but potential paradigm shifts in our understanding of the universe. Meanwhile, theoretical physicist Michio Kaku has recently suggested that quantum computers might hold the key to unlocking dimensions beyond our perception, a concept that, until now, has been purely theoretical. If these anomalies are real, Google's Sycamore may have just taken the first experimental step toward proving the existence of parallel realities. But here's where things get truly bizarre. Google's quantum chip detected something that even Einstein would have dismissed as science fiction. Did Google accidentally discover a new force of nature? Google's quantum experiment didn't just reveal an anomaly, it may have uncovered a completely new force of nature. Something beyond the four fundamental forces that currently govern the universe: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. For decades, physicists have speculated that there could be a hidden force, one that operates at the quantum level and could explain the missing link between general relativity and quantum mechanics. Now, the data from Google's Sycamore processor suggests this force might actually exist. The strange particle behaviors observed in the experiment didn't match any known interactions, leading some experts to believe that Sycamore may have detected a fifth force of nature. This has enormous implications for physics. If confirmed, this discovery could be the first step toward proving quantum gravity, the long-sought theory that would finally unite Einstein's laws of gravity with the unpredictable, probabilistic world of quantum mechanics. This is the missing piece that has kept physicists from formulating the theory of everything. And now, for the first time, there is experimental evidence suggesting it might be real. To put this into perspective, this potential discovery is being compared to Einstein's breakthrough on relativity, one that changed our understanding of space and time, and the Higgs boson discovery in 2012, which confirmed how particles acquire mass. Both of those breakthroughs transformed modern physics. If Google's findings hold up, this could be an even bigger paradigm shift, one that fundamentally rewrites the laws of the universe. Scientists around the world are now racing to replicate Google's results. If independent experiments confirm this data, it could lead to a complete overhaul of modern physics textbooks, requiring us to rethink everything we thought we knew about the universe. But until this discovery is fully verified, one major question remains unanswered. What exactly did Sycamore detect? The data anomaly that physicists can't explain. After the initial shock of the experiment's unexplainable results, Google's research team did what any good scientist would do: they ran the experiment again. In classical physics, repeating an experiment under the same conditions should always yield the same results. That's the foundation of the scientific method. But what happened next left physicists even more baffled. Google's quantum chip produced two completely different outcomes for the same experiment. The laws of classical physics say this shouldn't be possible, yet the data clearly showed that the system behaved one way in the first test and a completely different way in the second. It was as if the quantum system was responding to something beyond our reality, something unseen influencing its behavior in real time. Does this confirm the multiverse? For decades, the multiverse theory has remained one of the most controversial ideas in physics, a concept supported by quantum mechanics but lacking direct experimental proof. But now, Google's quantum chip may have just provided the first real-world evidence that parallel universes exist. The idea aligns with several prominent quantum theories, including the many-worlds interpretation, which suggests that every quantum event creates a branching timeline, leading to an infinite number of realities where different versions of events play out. If Sycamore's processor is interacting with multiple quantum states at once, it could mean that Google's machine isn't just calculating probabilities, it's accessing parallel timelines in real time. What happens next? The implications of Google's experiment have sent shockwaves through the scientific community. If what their quantum processor observed is real, it could completely redefine physics and open up possibilities that were once confined to science fiction. Physicists around the world are rushing to verify Google's findings. Replication is a key step in science. If independent teams can reproduce these anomalies under controlled conditions, it would confirm that what happened wasn't just a glitch, but a real interaction with quantum reality itself. This potential has already caught the attention of governments and private institutions, which are now investing billions in quantum computing. Some believe that whoever controls quantum computing will control the future, not just in science but in national security, artificial intelligence, and even space travel. If validated, this discovery could usher in a new era of quantum science, leading to groundbreaking developments such as quantum-powered AI that can process information faster than any supercomputer, time manipulation, where quantum particles interact in ways that could redefine our understanding of causality, interdimensional travel, if quantum computers truly enable us to access parallel realities. If Google's findings are verified, we might have just found the first experimental evidence that the multiverse is real. We are standing on the edge of a new era in physics, one that could reshape our understanding of the universe, time, and reality itself.